with. So x times x minus 3. If you do not put parentheses, you're not multiplying this by this. We are only multiplying x by x. So you must have parentheses. So this is the same with x squared minus 3x. And they are telling us that area is 28. So how do we proceed? We're trying to solve this equation, and the first step is anyone, please? What will be the first step?
Gonna start asking us my name, I guess. Gonna move to 28, I guess.
Good. Good. So we have to factor. Can anyone give us the factored form? Can anyone give us the factor form? Knowing that the product is negative 28 and the sum is negative 3. We need the positive and the negative.
X minus 7, x plus 3.
You mean 4. Yes, perfect. So then x equals 7 and x equals negative 4. Algebraically, both solutions are okay, but this is not okay because x cannot be a negative number. So the only solution in this case is length 7, do we know what it was in feet or inches or something? I'm going to put feet. And 7 minus 3 with 4 feet. Good. I would like us to go back to the review. I created a test 3 modules, 5 and 6. I will remove it. I will unassign it after the test so that it does not mess up your overall grade. This is not a mandatory assignment if you want to work with it, which I will definitely recommend in preparation for the test. But if you don't want to, that's fine. It will be unassigned after next Tuesday. Okay, so let's see what type of problems we review here. Is this a polynomial? 5m to the 4th minus 1/5 m to the 6th plus 4m. The question is this expression a polynomial? If it's a polynomial, we say yes. If it's not, we say no, of course.
No.
This is a polynomial. It's degree 6. It has coefficients 5, negative 0.2, and 4. It is a polynomial. Is a polynomial. The expression in standard form is, and I would, of course, the degree is 6. In standard form, which means the descending order, will be negative. I'm not going to put all those in, but okay, negative 1/5 m to power 6, and then plus 5m to power 4, and then plus 4m. Okay, this is a trinomial because it has 3 terms. Oh, it's not going to even tell me anything because it's a test. Okay. Do we need to work on addition of two polynomials? Okay. Do we need to work on this, or I have to enter something?
Yes, can you work on that, please?
Yes. So let's work on it. So we have 1/4 b squared minus 1/3 b plus 5 plus, parentheses are not needed when we add. We just have to be careful to copy correctly. Good. So I have 1/4 b squared and 1/8 b squared. The least common denominator is 8. So this needs a 2. So it would be 2 plus 1, which is 3. So I found the leading coefficient, which is 3/8. The degree is 2. I'm moving on to the next in line. So negative 1/3 b and 5/6 b. The least common denominator is 6, and I have to multiply this by 2 as well. But 5 minus 2 is 3. 3 over 6 is 1/2 plus 1/2 b. And finally, 5 minus 9 is negative 4. And this is it. So I combined like terms. I added or subtracted fractions. I presented in descending order. And this is it. Okay, moving on. Any questions on this? Evaluate the polynomial. Do we want to evaluate for any of the variables, the values of the variable, or not? Do we want to evaluate? Yes or no? So let's evaluate for the first one. So we have this polynomial, and we're asked to evaluate for negative 3. So when x equals negative 3, I have to replace it in parentheses, as we discussed a long time ago, because I have to show that I square x, but x is negative 3. So I have to put it in parentheses, because when I square negative 3, I get 9, not negative 9, but 9, and 9 minus 9 will be 0. You can also check with the graphing calculator. I highly recommend follow these steps. In y equals, put in, so this was 9, minus x squared. We go to second and table, and you plug in the numbers you need. So we needed 3 numbers. Negative 3, 1.5, 2.5. So negative 3, 1.5, and enter, and 2.5, and enter. Do not do it step by step, all from scratch. Put the function or the expression in y equals, and then plug them in. Okay? Good. If I don't enter something, it won't allow me to continue. Okay, do we need to simplify this? It will be 4 to which power? 4 to which power, please? This is an exponential rule. 4 raised to which power? Please, anybody, 4 raised to which power? 4 to the third, everything squared. We copy the base, what happens to the exponents? Anybody would like to try this?
Is it 3 times 2?
Yes. Now, the problem may ask you to determine, thank you. So the problem may ask you to find the answer. In other words, simplify. So 4 to the power of 6, and then hit enter. So it's 4096. Good. Okay, so this is a very important type of problem because you have to be careful with the sign. Yes, you can, I don't recommend this, but you could, but it won't work in all situations. You can copy this and then multiply these two. I don't recommend that step because it works now, but it will not work in other cases. Or it may not work in other cases. So do it step by step. -1 to the 5th is negative. X to the 5th is x to the 5th. And now take it to the third power. -1 to the third power and x to the 5th to the third power. We use the same rule and we get 15. I recommend do it step by step. It may or may not work if you do it directly, but I recommend, I think it's safer to just do it step by step. There may be other ways. I recommend step by step. It's up to you. Okay. Do we need to multiply these two? Anyone?
Yes.
Yes, very good. So this is a simple situation. I'm saying simple because all we have to do is just multiply 9 times 7. X to the 5th times x to the 4th. We copy the base. What happens to the exponents?
Add them.
Yes, perfect. Copy the base, and again the same thing, add them. So this is it. There is nothing else you can do here. 63, x to the 9th, y to the 9th. Good. We discussed this. I know you're able to multiply these two, but let me know if you want me to show. Yes? No? Okay. The same thing here is this identical problem with the previous one. Okay. Do we have any difficulties multiplying a binomial and distributing to a trinomial? Or do you simply want me to show it?
You just simply show it.
Yes, of course. Okay, so it's x minus 4 and x squared plus 3x plus 1. So we distribute x to those three terms. So we have x to the third plus 3x squared plus x. This times this is here, this times this is here, this times this is here. Now we distribute -4. -4x squared, -12x, and -4. -4, -12, -4x squared, -4x, and -4. Now we have to present it in descending order, also called standard form if you want to quote the book. So the degree is 3, so I have to start with x to the third. And then I have to combine like terms, these two into negative x squared. And then these two into negative 11x. And then minus 4. And if I'm asked to find the degree, I will say degree 3, descending order, and the leading coefficient is 1. Any questions on this problem? Okay, let's move on. Okay, the same thing, but let's work on this one, because I need to make a point. I did make it many times before, but let me make it again. In general, you should not ever look at the monomial in front. You should always multiply these first. There may be special cases in which you can distribute only to 1. You do not, this is not the distributive law. These are 3 factors multiplied. This is not that you have to distribute this here and this here. No, no. So that's why I highly recommend multiply these 2 first, and at the very end, distribute the monomial. So for now, let's copy it as negative 1/3 x. 3x times x is 3x squared. 3x times negative 3 is negative 9x. 9 times x is positive 9x, and 9 times negative 3 is negative 27. Luckily, these two go away. I copy negative 1/3 x. I still have 3x squared and minus 27. And now I distribute this to this term and to this term. Distribute monomials 99% of the cases at the end. Negative 1/3 times 3 is negative 1. X times x squared is x to the third. Negative 1/3 times negative 27 is positive 9. And then times x. And this is it. Could you have, I just don't want to confuse you. Could you have just distributed this in here and make your life easier? Potentially, yes. But in general, don't look at the monomial in front, if there is one. Multiply the binomials or trinomials, whatever they are, and then at the very end, distribute this to all terms. We discussed this procedure some time ago.
Thanks for showing it again.
My pleasure. We need to review and repeat and repeat, review and repeat. Okay, we had an example like this. Together, look at it and say yay or nay.
Sure.
Okay, so here we have n plus 4 and n minus 4. Let me change it to x, it's easier to understand my handwriting. Sorry about that. And x plus 4 squared. I know a special product for this, and I'm going to get it right away. I'm not going to FOIL it. I know the special product. X plus 4 times x minus 4 is x plus 4 times x minus 4 is which special product? Which special product is x plus 4 times x minus 4? Anyone remembers the special product x plus 4 times x minus 4? No one remembers the special product?
Perfect square?
Yes, the difference of perfect squares, which is
X squared?
that's it? It cannot be just one term. We don't have a special product with one term.
You said minus 4?
But you squared x, why don't you square 4? It's the difference of perfect squares. So you squared x. Correct. But you have to square 4 as well. It's the first term,
60
and then the sign.
X.
The sign.
Plus?
But it's called the difference of perfect squares.
Oh, sorry. Minus.
Minus 16. Good. Plus. Anybody remembers the special product of x plus 4, everything squared? X plus 4, everything squared. How many terms will it have? When we square a binomial, how many terms do we get? When we square a binomial, how many terms do we get? When we square a binomial, how many terms do we get, please?
Is it 3?
Yes. Can anyone give us those 3 terms? Can anyone give us the special product x plus 4 squared? If you're still foiling it, you're going backwards.
X squared, 8x?
Yes,
16?
yes. These two go away. So then we have 2x squared plus 8x. So this is the simplified form of that expression.